had a cube named Marley, and we were reducing its sides with a reduction by a factor of 1/3, this would be the new Marley, where all the sides are 1. Can you see that the volume of the old Marley would be length times width times height would be 27 units cubed. And the new volume, when you did it by 3, is 1 times 1 times 1 is only 1. So when you reduce something by a factor of 1/3, you're doing that to the dimensions. But since volume is length times width times height, and the length has been reduced by 1/3, the width has been reduced by 1/3, the height has been reduced by 1/3, the volume gets reduced by 1/27 as a result. This isn't on your sheet. This is just a review of Marley and enlargements and reductions. Okay? Now, we're into scale diagrams, because one of the most typical places that reductions are used or enlargements are in scale diagrams, right? You open up your biology textbook and they show you a cell, but they never draw it actual size. Frustrates me. Like, come on. I just want a, on my, like, here. And then on the test, I'd be like, done, labeled it, did everything. But no. So sometimes we need enlargements, sometimes we need reductions. We already saw that a map is one of those places where you need to have a reduction because it's way too big. So when we draw our scale diagram, we do 1 to 10 like this, and then the scale factor would be, the drawing is 1/10 of the actual object. A map scale, this is where we had left off. A map scale is that 1 centimeter equals 200 kilometers. This would not be a very good scale to draw the city of Winnipeg, because then everything would be fit into a very tiny bit. But it might not be a bad scale if you were drawing a map of Canada. So Calgary is roughly 1,400 kilometers from Winnipeg, and if your scale is 1 centimeter is 200 kilometers, you need to figure out, if you had 1,400 kilometers, 7 centimeters would make sense. Now that is something that some of you could just see with mental math. If I chose something that wasn't a nice number, let's say the distance from Winnipeg to Edmonton was 1,567 kilometers. Now your mental math doesn't let you figure out this number as easily. You could estimate it for sure. It's got to be more than 7 and less than 8. But how would you do it exactly?
Well, 7.5 would be.
Okay. If you take your 1567 and divide it by 200, oh, you ready? You're trying to. No, I haven't turned it on. If I had, here we go. I turned on my calculator. I was going to do it, but you can verify that has nothing on there. I've got this.
No way.
7.9. point.
Oh, I think I 7.3.
7. No? Okay, I'll work at it again. Oh, I thought you had calculated. I thought okay. Okay, let me just think.
Yeah, no, you're wrong. You're
Okay,
wrong.
no.
Yeah, I know you lost it on the answer. Yeah. Oh, wait.
835?
Yeah.
Bam. 7.835. So that would be the number that would go. How did I know?
You got it wrong first, though.
Well, I took 167 over 200 would be what's left for the decimal. Okay? I multiplied each of those by 5. Whoops. And got 835 over 1,000. And that's a thousandths, so then I could write that as thousandths. I got that in my head. That's not a bad estimate. Okay? Okay. On the same map, the distance from Winnipeg to Toronto is 22 centimeters. So now this time we have this side, and we need to figure out how many kilometers. And what do we know? We know that 1 centimeter is equal to, or the scale is 200 kilometers.
I don't think that means anything.
All right. So here, in the last one, when we worked backwards, we had to divide. When we work forwards, you would have to multiply. So you could take 22, times it by 200, because each centimeter is 200, and you would get 4,400 kilometers. Anybody planning on walking to Toronto this summer?
It's only
Okay.
22 centimeters.
It's only, yes. If you could only get it, scale yourself down or up, yeah. What would the scale factor be that you'd have to multiply yourself by? 200. No, it's because it's centimeters, kilometers, so you'd have to be like, you'd be like huge giant. Then I'm in Toronto, and then you shrink back down.
200 kilometers like tall.
Okay. The distance from the North Pole to the moon. So we have to draw a little picture of this. Here's the. I'm going to put the North Pole confusingly on the side, so that means I have to draw. Canada, that's North America and South America, and there's the North Pole. Here's Europe, a bit of Africa, here's a little bit of Australia, and some of Asia. There we go. And then the distance to the moon, there's the man on the moon. And in reality, what kind of scale would probably work for this? I might do 1 centimeter to 100,000 kilometers. Because then how long does this have to be? 3.825 centimeters in length. Excuse me. Yeah, almost the same number. So we need to describe in words what this scale means. One centimeter on what? On the drawing is 0.1 centimeters in reality. So is your drawing bigger or smaller than the object? The drawing is bigger than what the object actually is. So this would not be a good scale if you're like, ooh, I want to draw a car. Because then your drawing would have to be bigger than the car. What would be a good thing to draw using this scale? An ant. Okay. Do you see that the drawing is 10 times bigger than what the object actually is? So an ant that's this big, you could draw like, ooh, that's pretty big. Okay. Or did you mean this? Just checking. No? Okay. I spelled ant as in aunt and uncle. Yeah, I'm going to draw my ant.
Yeah, you say aunt, not aunt, right?
I say ant.
Does anybody say aunt?
No, no one's from Southern Ontario.
If I was,
In Miss Vidal's class, there was like three kids who say aunt.
if I was comparing ant and aunt, like or ant and ant, then I would say aunt. But if it's just an ant, if I'm saying, oh my aunt.
Aren't you clever? Okay, nice. Dimensions of your room are 4 meters by 2.5 meters. Is that a good size room? That's pretty. At the 2.5 might be a little bit small, but the 4 is actually, because most rooms are like 10 feet by 10 feet.
Mine's like, I don't know,
9 foot by 11 foot.
I've lived in like townhomes and stuff. So
How big are the rooms?
the rooms are usually pretty big.
Okay.
Like meters.
No, but you're thinking most of them are measured in feet. The standard room is around 10 feet by 10 feet. So 4 meters is around 12 feet, but 2.5 meters is around 7.5, 8 feet. So go measure your room. That's your homework. How big is your room? And then some of you are going to say, oh, actually, you have to live under the stairs in my house. Harry Potter style.
Funny because I just watched like Fantastic Beasts.
Ooh.
It totally is.
there's no comparison. There's one
Free
no
Harry
comparison.
Potter.
Yeah.
But there's no comparison between them.
Yeah, there totally is.
Okay.
No,
Have you
there's
just
no.
watched The Secrets of Dumbledore? It was amazing. It's brand new.
How about for a scale? You want to make something on your scale be 1 meter. What would you use as if you had to draw? Yeah, 1 centimeter. That sounds great. 1 centimeter equal to 1 meter. I guess I should use not equals, but the dots. There we go. That would be a good scale diagram. 1 centimeter on your drawing is 1 meter in reality. So then you could draw out 4 centimeters by 2.5 centimeters. Is this useful? Absolutely. Okay? If you ever want to design something, okay? Right? Like in our house right now, we decided to refinish our basement, and I drew the whole basement out by scale on graph paper so that I knew all the measurements exactly where they were. So when the house was built and I wanted to put a shelf, it fit perfectly. Okay? So you can do those kind of design things if you think it through beforehand. And one of the best ways is to draw a scale diagram. Okay? When a company builds a new house, they have to draw everything to scale to get the proportions. And for the house that I'm building right now, the architect that was drawing it actually got every measurement of every couch, table, and bed that we owned and said, yeah, this room is going to work or this room is not going to work. Your couch is too big or too small. Rather than moving in and going, oh, this room doesn't look right because it's not measured out beforehand. And some things are not very cheap to redo. Okay? Lots of math goes into things beforehand because you don't want to redo them. You're like, oh, SpaceX, we're going to go to the moon. We're going to build a spaceship. Yeah, this one looks like it's not going to work. Let's start again. Let's build it again. Any volunteers to go up for the test run? No. Yeah. You want to make sure things are working well enough before you do them. All right. You have captured an ant and want to enlarge it on a scale drawing. This question went bad, right? You captured an ant and it somehow morphed into a mosquito. This is crazy. And the mosquito now measures 3 millimeters by 2 millimeters.
Thank you, JB, for taking us on,
Yeah,
taking us on this amazing journey.
yes, this makes it more interesting when things like this happen. Okay? Oh yeah, we're still recording. So, determine a scale factor that would be nice. So in actuality, we have things in millimeters. So I might make 1 millimeter on the actual side. But I'm not going to draw 1 millimeter. I'm probably not going to draw, what unit would you probably have on this side? Centimeters seems like it'd be good. 1 centimeter, 1 millimeter. That's a nice, sometimes those scales that are really easy like that work really well. But let's say you draw it, and you end up drawing it, this would be, here we go, 1, 2, 3, 3 centimeters this way. This beautiful mosquito, there it is. 3 centimeters this way, and 2 centimeters this way. Yeah, it's a beautiful mosquito. I drew it after I slapped it, so it might have looked better before. No, because it was moving too much. I was trying to draw it. I was trying to draw. You, like, okay. I guess you guys haven't evolved your stick figure skills. Like, most of you are pretty good at this one. But have you drawn stick figures of other, like, how do you tell the difference between a stick figure cow and a stick figure horse? Those are important skills, right? This is officially the stick figure squashed mosquito. Squash, okay, that's Spanish. Anyways. So let's say you drew it and you didn't feel it was big enough. Let's say you decided you wanted to make it bigger so that it was 4 centimeters, let's double it, by 6 centimeters. That would be better for your scale diagram. Now, what's your new scale? 2 centimeters is 1 millimeter. Good. That would work. So we're allowed to think about how we could change the scale, because sometimes you pick a scale and go, oh, it's not quite big enough, but now I need to make a new scale. How would I do that? Can you see that this one is also the same as this one?
Seeing scale diagram this way is really helpful to fully understand scale.
Yeah, because just writing the scale really doesn't have meaning until you put it into a picture. That's why the stick figure mosquito is so helpful.
I haven't seen many questions where you have to actually think of a scale factor.
Yeah.
Usually I've not done that.
Are we gonna do that project?
Okay.
The one with like the cartoons?
Maybe at the end of the year. I'm going to leave that one if we have time at the end.
We should do it because the last thing is optional.
Yeah, so we'll make that optional too.